Section 9.3, Other Identities. Now, the other day we talked about how to derive all the identities, so what I would do is I would pause the videos and see if you can write them down from memory. Okay, so here are the double angle identities, the power reducing identities, the half angle identities, so make sure you have them memorized, and also these are the other forms for the cosine double angle, and also these are the other forms for the tangent half angle identities. So again, make flashcards or do what you need to do to have those memorized. So let's go ahead and look at the first question. The first one says, use the subtraction and addition identities to find the exact value of sine of pi over 12. Now, remember, the reason we did this is because pi over 12 was not on my unit circle. And so we looked at it and we wanted to use the addition or subtraction identities in order to find things in my unit circle so I could find the exact value. So that's when we did the sine of 3 pi over 12 minus 2 pi over 12 because that's equal to pi over 12. And then when we reduced it, we got the sine of pi over 4 minus pi over 6, and that allowed us to use our subtraction identity for sine. And then that gave us values on our unit circle so that we could find the exact value of what the sine of pi over 12 is equal to. So this is root 2 over 2 on my unit circle times root 3 over 2 minus root 2 over 2 times 1/2. And when you simplify this, you end up with root 6 minus root 2 over 4. And that was, again, finding the exact value. And of course, there's other numbers that I could have used that add up to pi over 12 or subtract 2 pi over 12. That would give me the same solution. So now we have another way that we can find the exact values, and it's using the half angle identities. So when you're using the half angle identities for sine, the first thing I would do is write out what my half angle identity is. So the sine of x over 2 is equal to plus or minus the square root of 1 minus cosine x over 2. Now for this, remember that in order to figure out what your signs are going to be in front, if it's a plus or a minus, you have to figure out what quadrant pi over 12 lies in. So pi over 12, if you convert this into degrees, if it helps you to figure out what quadrant you're in, you can multiply it by 180 over pi, which gives me 15 degrees. So I know that I'm in quadrant 1. And in quadrant 1, everything is positive, so I know I'm going to use the positive square root for this. The other thing I need to look at is, notice in my equation, I'm doing x over 2. I'm not putting this into x. I have to figure out what that x value would be in order to give me something divided by 2 gives me pi over 12. So what I do to figure out what that x is, I'm going to set up a nice proportion. Pi over 12 equals x over 2. That's going to allow me to solve to figure out what x should be. So how do I solve? I multiply both sides by 2. And when I do that, 2 pi divided by 12 gives me pi over 6 is equal to my x value. Now the reason this is nice when you're doing your half angle identities is because notice that pi over 6 is something that is on my unit circle. So that's why we use this half angle identity, and we figure out, well, what divided by 2 would give me something on my unit circle that's equal to pi over 12 instead of things that add up to pi over 12. Now we're doing something divided by 2 that's on my unit circle that's going to be given in the equation. So now for x, I do the sine of my x, which is pi over 6, divided by 2, because if I did pi over 6, just to show you, divided by 2 is the same thing as multiplying it by 1/2, and that gives me pi over 12. So that's where that comes from. Now, in my formula, we just said we know it's positive because we're in quadrant 1. We have the square root of 1 minus cosine. Notice this is cosine x here. So we don't plug in pi over 12, and nor do we plug in pi over 6 over 2. We're plugging in pi over 6 for x. So minus the cosine of pi over 6 divided by 2. And now I can use my unit circle in order to help me simplify this problem. So it's, again, the positive square root of 1 minus the cosine of pi over 6, which is root 3 over 2, divided by 2. Now, in order to finish this, I need to simplify. So I, in the numerator, need to get a common denominator between 1 and 2, which is 2. So I'm going to multiply this by 2 over 2. When I do that, I end up with the square root, and remember it's a positive square root, of 2 minus root 3 divided by 2, all divided by 2 from this in my denominator here. And I'm going to put that 2 over 1 so that when I flip it, I remember that I'm multiplying by the reciprocal. So I have the positive square root of 2 minus root 3 over 2 times 1/2, which is equal to the square root of 2 minus root 3 over 4, because 2 times 2 is 4. And then I get the square root of 2 minus root 3 over the square root of 4, because we don't like fractions underneath our radicals. And then the square root of 4, remember, is just really equal to 2. So remember, it's a positive square root of 2 minus root 3 over 4. Or, sorry, over 2. Because the square root of 4 is 2. And this would be my solution. Now, it doesn't quite look like our solution that we had up here, the root 6 minus root 2 over 4, but it's still an exact solution. We're just not going to simplify the radical with the radical any further, so that is going to be my answer. So again, it's just a different way of using values that would be on your unit circle, and we're, instead of using the addition and subtraction identities, we're using the half angle identity. So let's go to the next one. So now for this next one, I want to do the tangent of 7 pi over 8. So the first thing I would figure out is what quadrant is 7 pi over 8 in. So if it helps you to put this in degrees, if you don't know, 7 pi over 8 times 180 over pi. So when you do this, you get 157.5 degrees. That tells me I know I'm in quadrant 2. So if I'm in quadrant 2, then think about your tangent. Tangent in quadrant 2 is going to be a negative. Now, remember I have the other forms for the tangent half angle identity. So I'm actually going to use one of the other forms because I don't like using the one with the square root, because then I have to worry about if it's positive or negative. If I use the tangent half angle identity for 1 minus cosine x over sine x, then I don't have to worry about what quadrant that lies in. So this one's going to be a little bit easier, so I'm going to do that one instead. So for this, I have to figure out what that x value is going to be. So take 7 pi over 8 equals x over 2 to help you figure it out. Multiply both sides by 2, and you get 7 pi over 4 is equal to x. So that is what's going to go in here for x into my equation. So I have the tangent of 7 pi over 4 divided by 2 equals, and notice that we're only plugging in x into our equation. So I have 1 minus the cosine of 7 pi over 4 divided by the sine of 7 pi over 4, because that's what we're plugging in for x into our equation. And now I have to simplify this because the cosine of 7 pi over 4 is on my unit circle. So I get 1 minus root 2 over 2 divided by the sine of 7 pi over 4, which would be root 2 over 2. And then I have to, and sorry, that's negative, and then I have to go ahead and simplify this. So in my numerator, I need a common denominator, so this would become, multiply that by 2 over 2. So when I do that, I get 2 minus root 2 over my common denominator divided by negative root 2 over 2. And now I have a fraction divided by a fraction. So in order to solve a fraction divided by a fraction, remember you multiply by the reciprocal. So 2 minus root 2 over 2 times the reciprocal of what's in my denominator. So that would be 2 over negative root 2. These end up canceling out. So when I cancel those out, I'm left with 2 minus root 2 over negative root 2. I don't like to have radicals in my denominator, so I have to rationalize it by multiplying by root 2 over root 2. I don't have two terms, so I'm not multiplying by the conjugate, just the magic 1. So then I want to distribute. And when I do that, I get 2 root 2 minus root 2 times root 2 is root 4, which is just minus 2, over, again, root 2 times root 2 is root 4, so minus 2. And then we can factor out 2 from my numerator. And so when I do that, 2 divided by negative 2 is negative 1, so we get negative root 2 plus 1, or if we rewrite it, 1 minus root 2. And this would be my solution, and you can write that either way. Usually I like to write the positive number first. So that would be the exact value of the tangent 7 pi over 8. An easy way that you can make sure that you're doing this correctly is plug it into your calculator, make sure you're in radian mode, do the tangent of 7 pi over 8, and then plug into your calculator 1 minus root 2. Do the decimals match each other? And they should. So we're going to skip number 3, and we're going to go ahead and go to number 4. So for question number 4 here, it says we want to find the sine double angle, cosine double angle, and tangent double angle, given that the sine of x is equal to 5 over 13, and we're in the first quadrant. So for these, again, I know I'm in the first quadrant because we're in between 0 and pi over 2. So I want to find the sine double angle. So I'm going to write down my equation. So sine of 2x is equal to 2 sine x cosine x. So in this equation, the only thing that I know right now is I know what the sine of x is equal to. So 2 times 5 over 13. I do not know the cosine of x, but I can find it using my triangle or Pythagorean identities. So if I use my triangle, I know that I'm in quadrant 1. Remember, you make your triangle with your x-axis always, and this would be the angle, and sine is opposite over hypotenuse, which would be 13. So if I want to figure out what the other length is equal to, I can use the Pythagorean theorem. So if this is a, I would do a squared plus 5 squared equals 13 squared. So a squared is equal to 13 squared minus 5 squared. So a would be equal to the square root of 13 squared minus 5 squared, which is equal to 12. So now that I know that, I can figure out then what the cosine of the angle of x is, which is your adjacent 12 over hypotenuse 13. I could have also used my Pythagorean identities to figure that out. So if I would have done the cosine squared of x is equal to 1 minus sine squared x, an identity that we learned. So the cosine of x would be equal to, since we're in the first quadrant, it would be the positive square root of 1 minus your sine squared, which in this case is 1 minus 5 over 13 squared. So that would give me the square root of 1 minus 25 over 169. And then, of course, we would have to simplify this. So when I do that, I need a common denominator. This would be 169 over 169. So I get the square root of 169 minus 25 in my numerator, which is 144 over 169. And the square root of 144 is 12 over 13. And that's where that comes from. So that's another way of finding what the cosine of x is equal to. So two different ways. So when I plug that into my equation here, I get 12 over 13. Remember, to multiply fractions, you multiply your numerator times numerator and denominator times denominator. So I'm just going to change this so it looks a little different. So this would be really 2 over 1 if it helps you, because you're multiplying 2 times 5 times 12 over 1 times 13, which gives you 120 over 169, and that would be your sine double angle with the given information. Now, if I want to find the cosine double angle, I can use the fact that I know that cosine squared minus x minus sine squared x is my double angle formula, and we just found cosine and sine. Or I can use my other form if I wanted to. So remember, one of my other forms for the cosine double angle is 1 minus 2 sine squared x. I could use that one, or I could use the other one. I'm probably going to use this one right here, only because I was given sine x in my equation, and that way I know if I use this formula, if I made a mistake finding my cosine of x, then at least I know I can get the cosine double angle formula correct. So 1 minus 2 times sine squared, which would be 5 over 13 squared, is what I'm really solving. So when I solve this, I get 1 minus 2 times 25 over 169. And so when I do that, I get 1 minus 50 over 169, and then I would have to get a common denominator, so 119 over 169. You could use your calculator to do that. So if I would have done instead cosine squared minus sine squared, I would have gotten the same answer. So 12 over 13 squared minus sine squared, so 5 over 13 squared. If you do that in your calculator, you get 160 or 119, sorry, over 169. So you end up with the same answer. So it's just two different ways of doing it. So now the last one I want to find is the tangent. So the tangent of 2x is equal to 2 tangent x over 1 minus tangent squared x. So if I want this, then I have to figure out what the tangent of x is equal to. So go back to my triangle. The tangent of this angle would then be equal to 5 over 12. And that's what I would plug into my equation. So I have 2 times 5 over 12 divided by 1 minus 5 over 12 squared, and then I could use my calculator to simplify this, and I would get 120 over 119, so that would be my tangent. Another way that I could do this problem, if I know sine and cosine double angles, if I know I did it correctly, then the tangent double angle is equal to, I could do sine 2x over cosine 2x, and I could use that. So my sine answer was 120 over 169, and the cosine was 119 over 169. So if I multiply by the reciprocal, these would cancel out, and notice I'd be left with 120 over 119, which is what we got up here. So two different ways of finding the same answer. So let's go back. So now that we have that, why don't you guys try to see if you can do this next one. It says find the sine double angle, cosine double angle, and tangent double angle given that tangent is equal to 3/4 and that x is in between pi and 3 pi over 2. So for this one, we know that we're going to be in quadrant 3 if you make your triangle. So I know in quadrant 3, if you think about all students take calculus, tangent in quadrant 3 is positive, but my sine and cosine should be negative. So see if you can do this on your own. We will do number 3 together in class, so you don't have to worry about that one. But let's look at number 6. So for number 6, it says find the sine half angle, cosine half angle, and tangent half angle, given that the cosine of x is equal to 0.4 for values of x in between 0 and pi over 2. Now, if you look at this, remember that when we want to find the answers for this, we have to know what quadrant that our angle is going to lie in. And remember that x is not the quadrant that our answer lies in. It's really the x over 2, which gives me my value. And if you just go back to the first problem that we did, you can see that this wasn't the quadrant that I needed to figure out for my sines. I had to figure out what pi over 12 is. So in order to do this next problem, since they only gave me the values for x, what I could do is I could change this and divide everything by 2 to figure out what quadrant x over 2 lies in, because that's what you need to figure out. So if I do that, I get 0 divided by 2, which is 0, is less than x over 2, which is less than, if I have pi over 2 divided by 2, it's the same thing as multiplying by 1/2, which is pi over 4. So notice that x over 2 is in between 0 and pi over 4, so I know that really I'm in quadrant 1 for my sines. So I know that sine, cosine, and tangent are all positive in quadrant 1. So that's the first thing that I would need to do, is need to figure out what quadrant x over 2 lies in for the first part. Now that I have that, I can figure out everything else, and we're going to do the exact value answer. So I'm going to change this into the cosine of x is equal to 2/5, because that's really 0.4. Now if I have that, if I want to find the sine of x over 2, remember it's plus or minus the square root of 1 minus the cosine of x over 2. Now that means I need to figure out what the cosine of x is. Oh wait, weren't we given what the cosine of x is equal to? 2/5. So I don't even need to figure out anything for this problem. I can just plug it in. And I know I'm using the positive square root because we're in quadrant 1. So I always like to circle it to remind me that it's positive. So 1 minus 2/5 over 2. Now I just have to simplify this. So in order to do that, I need a common denominator in my numerator, which would be 5 over 5. So 5 minus 2 would give me 3 over 5 in my numerator. So I have the square root of 3/5 divided by 2. And remember, when I have a fraction divided by a fraction, I multiply by the reciprocal. So I'm going to go down here. So I have the square root of 3/5 times 1/2, which is really equal to the square root of 3 over 10. We don't like to have fractions underneath a radical, so I have to simplify this into root 3 over the square root of 10. We don't like radicals in my denominator, so I need to rationalize that by multiplying by root 10 over root 10. And in my numerator, I get root 30 all over 10. So that would be my sine half angle. Now if I want to figure out my cosine half angle, my cosine half angle, again, is plus or minus the square root of 1 plus cosine x over 2. So again, I don't have to figure anything out because I already know what the cosine of x is equal to. I know I'm in quadrant 1, so it's plus the square root of 1 now plus 2/5 because that was the cosine of x all over 2. And now I just need to use my algebra in order to help me simplify this. I'm going to use a different color so we don't get messed up with the other one. So this would be 5 over 5. So this gives me the square root of 7 over 5 divided by 2 over 1, which would then be equal to the square root of 7/5 times 1/2, which is root 7 over root 10. Rationalize the denominator. Root 10 times root 7 is root 70 all over 10. So this would be my cosine half angle. Now, the last one I need to figure out is my tangent half angle. Well, if I know sine and cosine, that's easy to figure out because the tangent half angle would be equal to the sine half angle answer over the cosine half angle answer. So in this case, sine, my answer was, in this case, root 30 over 10 divided by cosine, which is root 70 over 10. So when we multiply by the reciprocal, I get root 30 over root 70. And then, of course, we don't like to have radicals in our denominator. So when I simplify, roots 70 times root 30 gives me root 2100 over 70, and then that simplifies into 10 root 21 over 70, which is root 21 over 7. Let's say I wanted to actually use the tangent, one of the tangent half angle identities. So another one I could have done for this is if we have 1 minus cosine x over sine x, and in this case we would actually have to figure out what sine x is equal to. We would know that we were in the first quadrant because we found that earlier, and I know that this is 2/5 because we were given that the cosine of x was equal to 2/5. So if I want to find sine, I would figure out that this is root 21, so the sine of x would be equal to root 21 over 5, and if I plug that in, I get 1 minus 2/5 over root 21 over 5, and then I would get a common denominator in my numerator, so this would be 5 over 5. When I do that, I get 7 over 10 divided by root 21 over 5. Sorry, that should have been 3/10 over root 21 over 5, which is 3/10 times 5 over root 21. Oops. Sorry. Again, 3/5. So then this would cancel out, and you're left with 3 over root 21. Rationalize the denominator. And when you do that, you would end up with 3 root 21 over 21, which gives you root 21 over 7. So just a different way of finding the same answer. So that's what we are going to be doing in this next section. So again, this is a little bit harder because you have to be able to know how to plug it into the equation and how to simplify by adding fractions, getting common denominators, multiplying by the reciprocal, and rationalizing your denominator. And then this one was tricky because we weren't given the actual angle like we were in the first problems. We had to figure out what it was equal to, only given a small bit of information. Unlike the first one that we did where we were given what the angle was and we wanted to find the exact value of this using the half angle identities. So make sure you bring this with you to class and we will practice more of this. And again, don't forget to do number 5 right here as well.